Minnesota has a salt problem. We don't think too much about salt because it's cheap, it's readily available, it's very functional. We've been using salt for our roads, for our winter maintenance since about the 1940s. What we didn't know is how much chloride was going through wastewater treatment plants and coming from water softening or agricultural practices, ending up in our streams, rivers, and lakes. Chloride is this invisible threat. We can't see it, we can't smell it, but it's there and it's really poisoning our water quality.
The EPA has set a standard about how much chloride can be in water. It's the equivalent of taking a teaspoon of salt and putting it into a 5-gallon bucket of water. Once it dissolves into the water, it doesn't go away. It doesn't settle, it doesn't float.
Chloride is a permanent pollutant. It really accumulates over time in our fresh water. It becomes an unhealthy environment for our fish, aquatic insects, wildlife and vegetation, and potentially the food chain.
So with support from the Environment and Natural Resources Trust Fund, we started a 3-year project at the University of Minnesota to develop a statewide chloride budget and then look at how Minnesotans could mitigate some of those negative chloride influences. It was a big undertaking to determine what are all the data sources we need and track down that data. There's actually salt purchase records on a statewide basis that then can be tracked to who used them. Did they go to a municipality? Did it go to industry? Did it go to make the salt we put in our softeners?
We also used different permitting data, water quality data, wastewater quality data, and groundwater pumping records to estimate chloride from commercial, industrial, and agricultural sources to put together the pieces of the puzzle.
One thing we really needed to figure out is how much salt people were using in their homes.
So we partnered with the Minnesota Water Quality Association to survey professionals on how common water softening is across the state, differences between softener efficiencies, and how much salt people were using at a household scale.
We found that there are still many inefficient models being used, which just means people are using more salt than they need to.
To understand some of the impacts of industrial-scale water softeners, we visited several rest areas and took samples from septic systems to estimate the amount of chloride leaving those systems.
There were 2 major takeaways from this project. The first was an overall statewide chloride budget. The second was a budget only focused on wastewater treatment plants. The easiest way I think about it was a pie chart. So 42% of the salt used on an annual basis came from road salt. Animal manure and commercially applied fertilizer was 25%. The remaining large chunk was coming from wastewater treatment plants.
We were surprised to find that over 65% of the chloride leaving our wastewater treatment facilities came from water softening. That's 137,000 tons of chloride put into our environment every year. About 200,000 tons of chloride are used annually on our fields, and about 400,000 tons to de-ice our pavements and our roads. We took the learnings and applied that to Sand Creek Watershed near Jordan, Minnesota, as a case study for agricultural communities. Our findings show the chloride coming from livestock and potash fertilizer was as high of a source as road salt in our urban centers. Using fertilizer according to our best practices is one of the best ways to manage some of the pollution in these watersheds.
The results of our research were published in journals. We spoke at many conferences, and other projects have been able to leverage that knowledge to fund related work.
Through additional support from the Trust Fund, our team at the Science Museum Minnesota is building on this previous research to develop models to understand when our salty lakes could reach their tipping point. One tipping point is the amount of chloride that actually kills organisms. The other is changing how lakes are mixing. We monitored 15 lakes over the course of 2 years, and there was a key organism we needed these lakes to have. Daphnia is a zooplankton, a small crustacean that's about 1 millimeter long and a keystone organism in the food web. From our genetic analysis it was really surprising to learn that some of these Daphnia are actually adapting to salinity. But unfortunately, we've seen some lakes that no longer mix because they have a dense salty layer at the bottom, and there's very little habitat for fish or people to enjoy those lakes anymore. If we don't change what we're doing, other lakes are going to reach this tipping point as well.
There aren't easy solutions, but I have yet to meet the Minnesotan who's like, I want to pollute my lake or my river. And so what we need more people to think about is the salt they spread on their sidewalks or the salt they're using in their water softener, that if they could reduce that, it could potentially help that lake that you love.
I'm proud that Minnesotans support the Environment and Natural Resources Trust Fund. And I'm really heartened by this sense that we're in this together, learning together about the impacts of chloride and some of the ways that we can push the science, different innovations, and raise awareness to protect our water resources in the future.